Dear Chairman, dear colleagues, let me introduce to you an article with the title Statistical Models Expressing Relations between Soil Moisture, Aggregate Speed, and Tillage Depth at Plowing and Cultivation. Authors Petya Veleva and Galia Christova. Objectives: Sunflowers is an oil-bearing crop used in the food industry, in animal husbandry, as a silage plant, and in the last decade it has become widespread in the production of pellets for heating. Bulgaria ranks fourth among European Union countries with 21.5% of total sunflower production. Plowing and cultivation are agrotechnical operations, part of the soil preparation involved in the technology of sunflower production. The uniformity of the depth of these operations is important for restoring the compaction of the soil, improving the penetration of water into the lower layers, changing the distribution of soil aggregates, and has a beneficial effect of the growth of plants. The purpose of this article is to monitor the stability of the machine tractor unit in terms of depth of tillage and cultivation, and to, to compile statistical models expressing the relations between soil moisture, speed of the aggregate, and tillage depth. These models could be used to optimize the management system of agricultural machinery. Material and methods. The experiments were carried out in the 2019-2020 agricultural year. The field on which the experiments were conducted is located in the Chirpant region in the central part of Republic of Bulgaria. It has been divided into two equal sections, both with dimensions of 530 meters long and 40 meters wide, shown on Figure 1. There are several types of soils in the field. Humus, carbonate soil predominate for the most part, but there are also traces of resin, leached typically clayey, and resin leached cinnamon, and slightly clayey. Data of soil moisture has been taken with IM128 soil moisture meter. Material and methods. The plowing is done with a 5-body reversible plow aggregate to a tractor with 200 horsepower at a speed of 4 km per hour in the first section and 4.5 km per hour at the second. When cultivating, the machine tractor unit consisted of a tractor 220 horsepower and a 9-meter cultivator operating at speed of 8 km per hour and 9 km per hour accordingly in the first and the second field. The period of execution and depth of processing of the technological operations applied in sunflower production are presented in Table 1. As can be seen from the table, the measured plowing depth were between 28 and 32 centimeters. The measured cultivation depth were between 14 and 16 centimeters. The tillage depth in centimeters was measured with a linear meter. Materials and methods. The effect of soil moisture on the depth of tillage for the agrotechnical operations, plowing and cultivation at different speeds of the aggregate was analyzed using two-way analysis of variance ANOVA and regression analysis. The aim was to compile predictive models defining the relations between the observed parameters. Level of significance P is less than 0.05 were considered statistically significant. Levene's test of equality of error variances was applied to check the homogeneity of the samples. 4 different regression models, linear 1, logarithmic 2, quadratic 3, and exponential 4, were compared with given formulas. The result was calculated within SPSS statistics. Result and discussion. Table 2 presents the result of the bivariate correlation method for the observed parameters depth of plowing, speed of the aggregate, and soil moisture at the level of significance P less than 0.05. The Pearson correlation coefficient R reveal that this is a very weak correlation between the factors speed of the aggregate and soil moisture. R is equal to 0.081, i.e. their influence of the studied parameters depth of plowing can be analyzed separately. The relation between the depth of plowing and speed of the aggregate is very weak. R is equal to 0.082. The relationship between the parameters depth of plowing and soil moisture, R is equal to 0.836, is strong and positive, which is a prerequisite for the creation of different regression models and the analysis of the influence of soil moisture on the depth of plowing. The calculated correlation coefficient of the studied parameters depth of cultivation, speed of the average, and soil moisture at the significance level P is less than 0.05 are presented in Table 3. Similar to the previous results, Table 2, there is a very weak correlation between the factors speed of the aggregate and soil moisture. R is equal to 0.01, i.e. their influence of the studied parameters depth of the cultivation can also be examined separately. Regarding the parameter depth of cultivation and speed of the aggregate, a very weak and negative correlation has been registered. R is equal to minus 0.033. A strong positive correlation is observed between the parameters depth of cultivation and soil moisture. R is equal to 0.727, which confirms the need to create different regression models. Result and discussion. The average value of the observed parameter depth of cultivation of the agrotechnical operations, plowing and cultivation are presented in Table 4. As it can be seen from the table, there are no statistically significant differences between the average values of the depth of plowing and a unit speed of 4 and 4.5 km per hour. The same result can be seen for the average values of the depth of cultivation and unit speed 8 and 9 km per hour. This could be explained by the reported weak correlations between these parameters in Table 2. Result and discussion. Table 5 presents the regression equations showing the effect of soil moisture on plowing depth at a unit speed of 4 and 4.5 km per hour. At speed of 4 km per hour, all regression models are statistically significant at P less than 0.05. The value of the coefficient of determination of the quadratic model is the highest. R squared is equal to 0.682. i.e. about 68.2% of the variations in the depth of plowing are explained by the influence of the soil moisture. All calculated regression equation showing the influence of the soil moisture of the depth of plowing at a unit speed of 4.5 km per hour were statistically significant at p less than 0.05. In this case, the value of the coefficient of determination of the exponential model is the highest. R squared is equal to 0.729, i.e. the parameter soil moisture at the speed of the aggregate 4.5 km per hour affects the depth of plowing about 72.9%. Results and discussion. The estimation of the curves of the developed regression models expressing the relation between soil moisture and the depth of plowing in the respective speeds can be seen at figure 2. The quadratic model in blue best describes the studied dependencies at the speed of the unit 4 km per hour and the exponential model in green respectively at speed of 4.5 km per hour. Results and discussion. Table 6 presents the regression equations showing the influence of soil moisture on the depth of cultivation at speeds of the aggregate 8 km per hour and 9 km per hour. All models are statistically significant at p less than 0.05. The values of the coefficient of determination for both examined speeds are the highest for the quadratic model. R square is equal to 0.526 and 0.557, i.e. about 52.6% of the variations in the depth of cultivation are explained by the influence of soil moisture at speed of the aggregate 8 km per hour and 55.7% at speed of 9 km per hour. The estimation of the curves of the models determining the relation between soil moisture and depth of cultivation at speeds of 8 km per hour and 9 km per hour is presented in figure 2. The quadratic models in blue best describes the studied dependencies for both observed speeds. Strong positive correlations were reported between the parameters depth of plowing, depth of cultivation, and soil moisture. R is equal to 0.836 and 0.727, which justifies the creation of regression models. The average value of depth of plowing at a unit speed of 4 km per hour is 28.17 centimeters, and at 4.5 km per hour is 28.40 centimeters. The average value of depth of cultivation at a unit speed of 8 km per hour is 15.11 centimeters, and at 9 km per hour is 15.05 centimeters. It was found that the different speeds did not have a statistically significant effect on the depth of tillage during plowing and cultivation. The quadratic models best describes the influence of soil moisture on the depth of plowing at a speed of the aggregate 4 km per hour. R squared is equal to 0.682, and the exponential model respectively at a speed of 4.5 km per hour. R squared is equal to 0.729. The influence of the soil moisture on depth of cultivation for both observed speeds, 8 km per hour and 9 km per hour, is best defined with the quadratic model. R squared is equal to 0.526 and 0.557. The developed models could be used in the optimization of the control systems of the machine tractor units and to serve the farmers in the choice of some parameters for carrying out certain technological tillage. Thank you for the attention given.